Hello everyone, this is Teacher Harold, your junior high school math teacher. In this video, I'll discuss about graphs of sine and cosine functions. Now after watching the video, you should be able to determine the different properties and the behavior of the graphs of circular functions. And also, you should be able to draw the graphs of these functions. Now this is actually the continuation in the topic in the previous week. In this material, other than properties already discussed in the previous material, the translation of the graphs of sine and cosine functions is also included in the discussion using the forms f of x equals a sine of quantity bx plus c and f of x equals a cosine of the quantity bx plus c. Now let us discuss each of these two equations from sine and cosine functions. Now the graph of y equals a sine of the quantity bx plus c. Now what about this function? What can we say about the graph of this function? Now it is the graph of actually y equals a sine of bx, which is translated horizontally. The horizontal translation or phase shift is given by the formula negative of the ratio of c to b. Now c is actually taken from this function, which is the constant term, and b is the coefficient of x. Now if the value of c over b is greater than 0 or positive, we could say that we move c over b units to the left. And if the value of c over b this time is less than 0 or negative, we move c over b units to the right. Okay? Now this is for the graph of sine function having this equation. Now what about the other graph of the function, this time when it comes to cosine function having this equation? What can we say about the graph of this function? So basically, it is similar to what is being said about the graphs of sine function from uh, this first item. Now it is actually, now for the graph of y equals a cosine of quantity bx plus c, it is the graph of y equals a cosine bx, which is translated horizontally. The horizontal translation or so-called phase shift is given by the formula negative of c over b. Now, if c over b is greater than 0 or positive, we move c over b units to the left. And if the value of c over b is less than 0 or negative, we move c over b units to the right. Okay, so let us have some examples for us to fully understand what this topic is all about. Okay, now let's just say, for instance, we have the function y equals sine of the quantity x minus pi over 2. So basically we're going to try to trace the graph of this function. So this is the solution. So first we need to know three things about the graph of this function. These are the amplitude and the period. Okay, so for the amplitude, we just consider the coefficient of sine, and obviously that is equal to 1. So we get its absolute value. Okay, then for the period, we can determine the period by this formula, which is the absolute value of 2 pi over b, where b is taken from the coefficient of x, and obviously the value of b is equal to 1. So 2 pi over 1, we automatically get its absolute value, so that is equal to 2 pi. Then from the from the from the obtained period, we're going to divide this into 4 equal parts. Okay, so the first part can be determined by p over 4, and we substitute the value of p, which is what you call this, 2 pi. So that is pi over 2. So how did we get pi over 2? Now, ganito yan, no? So, we know that P is obtained from number 2, which is 2 pi. So, that will become 2 pi over 4, or you simplify that, that is pi over 2. Okay? Now, for the second part of the period, we take the formula P over 2. And again, substituting the value of P, which is 2 pi, so that is 2 pi over 2, which is equal to pi. And the third equal part, the third equal parts of the period is taken from this formula 3p over 4, and we know p is equal to 2 pi, so substitute, and we simplify the result as 3 pi over 2. And finally, the entire period p, which is obviously equal to 2 pi. Then, after determining these three things, we can now trace the graph. The graph of, not necessarily this one, we consider first the graph of the mother function of this given function. Okay. And the mother function is actually equal to y sine of x. Now, in order for us to graph the mother function, of course, we need to prepare the Cartesian plane. So this is the Cartesian plane. The yellow vertical and horizontal lines represent the y and the x-axis respectively. And for each axis, each of the axes, we label the coordinates. Okay. Now for the coordinates along y-axis, we can consider the amplitude 1. So we consider both positive or negative. So for positive 1, that is the coordinate of the y-axis above the x-axis, and negative 1 is the y-coordinate below the x-axis. Then for the coordinates along the x-axis, we could do some scaling. The first one is 0, which is the intersection of the two coordinate axes. Then we can consider 2 units, which corresponds to 2 pi. Okay, another 2 units, so that is pi. Then another 2 units for this one, we have 3 pi, and then 2 pi. Then okay, so we simply graph the mother function of this one, and that is y equals sine of x. Then okay, from the figure, you plot some points. You start with the origin, because we're considering sine function. So basically, the graph will start from the origin. And then we consider pi over 2. And where shall we plot the point? Of course, after the origin, we plot the point here. Okay? Now, how did we know that the plotted points should be placed here? Tapat ng 1 at tapat ng pi over 2. Okay, so basically, we could use this equation and we substitute the value of x. The value of x is taken from this one, pi over 2, and we know that sine of pi over 2 is equal to 1. Okay, then for the next part of the period, which is pi over 2, which is pi, so we consider sine of pi, and we know that is equal to 0. Now this is where you plot the points. Yun. And then the next part is 3 pi over 2, and we plot the point here, no? At 3 pi over 2 value of x, therefore the value of y is equal to negative 1. And then finally, for the complete period p, we plot the point here. Yun. Then, using those plotted points, we use smooth curve to connect them. Okay? Yun. Okay? Okay. My emphasis here is the orange. I don't know. Okay, this is a light red color, lighted red color. The portion of the graph is the period, okay? And the excess of the graph is uh, a portion of the other period, okay? Both left and right. Yan. Then after tracing the graph of the mother function y equals sine of x, what comes next? Okay, we're going to determine the value of phase shift. Okay? And that can be determined by the formula negative c over b. And c is taken from the constant term which is found inside the parenthesis, that is pi over 2, or negative pi over 2. Now, we consider the sign, so that is negative pi over 2 all over b, whose coefficient is 1. Now, if we're going to simplify this, the value is pi over 2. So, the phase shift is pi over 2. What does this mean? It means we move to the right. The graph is to be moved. Now, this curve is to be moved by pi over 2 units to the right. Okay? Now, taking those 4 parts of the period from number 3, each of the values is adjusted by pi over 2. So, each value, we add pi over 2, which is the value of phase shift. Yeah. Okay? Yeah. So, from pi over 2, it becomes pi. From pi, added by pi over 2, that is 3 pi over 2. And from 3 pi over 2, added by pi over 2, we have 2 pi. And for the period p, the value is added by the phase shift value, pi over 2. So that is 5 pi over t over 2. Now, what does this mean? Now, ito yung i-consider na natin na adjusted value. Ibig sabihin, yung apat na nakuha natin, okay, we're going to trace another set of points which will be the final location of the graph if we're going to connect those four new points. Okay, but here in the graph, now there is an effect from the graph wherein there will be a translation. Okay, so we follow this step from number 5. We move the graph by 2 pi over 2 units to the right. So observe the graph from the Cartesian plane, particularly the color-coded graph, which is this one. And we're going to move this to the right by pi over 2. Now look what will happen. Okay. So if we're going to do that, we will have this given function. Okay? Or the graph of this given function. So ano ito mangyayari, no? Okay. Okay, observe that from a red graph, it is changed to blue. The blue graph is the one we're going to move to the right by pi over 2 units. Look. Okay? Therefore, itong graph na nakikita nyo, na ginalaw natin pakanan, ito yung graph nitong blue function na to. Okay? And that is how we trace the graph. Okay? Next. How about this one? The graph of y is equal to quantity x plus pi over 2. Okay, for our solution, okay, we do the same thing. We trace the graph of this function this time. And basically, we need these three. The first one is the amplitude, the period, and the four equal divisions of the period. Okay. For the amplitude, again, it is taken from the coefficient of sine, which is 1. Okay, so we get the absolute value. It is always positive 1. And then for the period, that is determined by the formula, the absolute value of 2 pi over b, or that is 2 pi over 1, which is the value of b. Again, the value of b is the coefficient of x, and that is 2 pi. And then from the obtained period, we're going to divide that into 4 equal parts. So that is in step number 3. Okay? So we consider the value of p over 4 and substitute p as the period. The value of p is taken from number 2. Ayun. So that is 2 pi over 4, or that is pi over 2. Then p over 2, again, substitute 2 pi divided by 2, that is pi. And then 3 pi over 4, substitute the value of p, and then simplify, that is 3 pi over 2. And finally, the entire period p, which is 2 pi. Okay? And then after carrying out the third step, we go to the fourth one. Okay? We prepare the Cartesian plane to graph the mother function of this given function. And what is that mother function? Again, it's y equals sine of x. Okay? Taking each of these four partitions of the period and substitute to this x from this given function, we can determine the corresponding value of y. Okay? And with that, we will obtain a corresponding point to be plotted in this Cartesian plane. Okay, so let's just say pi over 2. So that is sine of pi over 2, which is, we all know, equal to 1. Okay? Yeah. But first, since again we're talking about the graph of sine, the first plotted point is at the point of origin. Okay, so we have yet to use any of these four values. Okay, so we plot first the point at the origin. Okay, yon. And then that's the time for us to consider each of these four. Now for the first value, p over 4, we consider pi over 2 and substitute to as the value of x from this given mother function. So sine of pi over 2, we all know that is equal to 1. So at pi over 2, we plot the point which is coinciding or at the level of 1 of the coordinate 1 as the coordinate of y-axis. Okay. Next, for the second value, p over 2, which is pi. So sine of pi is how much? It's 0. So this is where we plot the point here. Okay. Not this one, dito pala. Okay. Now here. Then third one, this one, 3 pi over 2, which is the value of 3p over 2. Where shall we plot the point? So sine of 3 pi over 2, that is actually negative 1. So this is where you plot the point. And finally, the value of p, which is 2 pi. So sine of 2 pi, it's actually 0. So this is where you plot the point. And then you will notice that we have 5 plotted points starting from 0. So using a smooth curve again, you connect those 5 plotted points. Okay? Okay, that's it. Okay? Ayun. Okay, so then after we plot the graph of mother function y equals sine of x, we now go to the fifth step, which is determining the phase shift value, or the value of negative c over b. Okay. Now c is the constant term inside the parentheses, and b is the coefficient of x, which is 1. So that is negative of pi over 2 divided by 1, or that is negative pi over 2. What does this mean? It means that the graph is to be translated or moved by pi over 2 units to the left. Okay? Going to the left. So, taking each of the following values from step number 3, we're going to subtract each of these 4 by pi over 2. Okay? And pi over 2 minus pi over 2, that will give you pi, I mean this one. Ayun, yan, 0. Okay? Then pi over 2, the value of pi over 2 minus pi over 2, which is the value of the phase shift, that will give us pi over 2. Okay? Next, 3 pi over 4. 3 pi over 2 minus pi over 2 is equal to pi. And then, the final value of p from number 3 is 2 pi minus pi over 2. That is 3 pi over 4. So, at this point, we are about to move the graph to the left by how much? Pi over 2, which is the value of the phase shift, which is obtained from step number 5. Now, look what happened to the graph. If we move this graph to the left by pi over 2, the new position of the graph will be determined by, okay, sorry. The new position of the graph would would be can now be determined by this given equation. Yan. Y is equal to sine of the quantity x plus pi over 2. Okay, ayun. Okay. So the red color of one cycle has its new position from the Cartesian plane, and this graph has now this equation. Y is equal to sine of the quantity x plus pi over 2. Okay, next. Let us see about the graph of 3 cosine of the quantity 2x minus pi. So, just like the previous examples, let us try to graph this given function in letter C. So again, we need the first 3, the amplitude, the period, and the division of the period, which is to be obtained from number 2. So 3 is the amplitude, which is actually the coefficient of cosine, which is positive because of the absolute value from the formula. Then for the period, this can be determined by the formula, the absolute value of 2 pi over b, where b is equal to 2. And that value is taken from the coefficient of x, which is 2. Yan. So 2 pi over 2 is pi. So this is the period or the length of one cycle of the graph of this function. And then we divide the period into 4 equal parts. Ayun. Beginning with p over 4. Of course, p is equal to pi. So that is pi over 4. Then pi over 2 will become P over 2 will become pi over 2 because P is equal to pi. Then 3 pi over 4 is 3 pi. Then 3p over 4 is 3 pi over 4. Then P is equal to pi. Now we prepare the Cartesian plane to graph the mother function of this given equation. And the mother function is y equals 3 cosine of 2x. Okay, yun. With already labeled coordinates from both x and y axis. Okay, so we plot the point. Now, since we are dealing with cosine function, unlike in sine function, okay, we begin with the graph not at the point of origin but at the maximum value of the function, which is equal to 3. Okay? Wherein 3 happens to be what? The amplitude or the height of the function. Okay? Yan, 3. Then, using the first value, pi over 4, we substitute to this equation. Okay? So it becomes 2 times pi over 4 or pi over 2. Tama ba? Pi over 2. Cosine of pi over 2 is actually 0, so we plot the point here. Okay, next. For the second value, p over 2 or pi over 2, substitute to this equation for the value of x. So that is cosine of pi, which is actually equal to -1. Okay? But -1 must be multiplied by 3, so it's -3. Okay? Then for the third value of the period, so 3 pi over 4. Okay? So that is 3 pi over 2. Okay? Ayan. So this is where you plot the point. Ayan. Then for p, which is pi, substitute to this equation. So cosine of 2 pi is actually what? 1. Times the coefficient 3, that is equal to 3. So we plot the point here. Okay. Ayan. Dito yun, no? This is where we plot the point. Okay. Ayan. Now, what you see right now from the Cartesian plane is actually the graph of this mother function with an assigned labeled color, which is yellow-green, no? Yeah. Yellow-green is the color of the graph of the mother function. But of course, we're not done yet because that is not the graph we are looking for. We are trying to trace the graph of the given function. Y equals 3 cosine of the quantity 2x minus pi. So for step number 5, okay, we compute for the horizontal translation or the so-called phase shift. And obviously the formula is negative c over b. Now substitute the value of c, which is the constant term, which is negative pi, over b, which is equal to 2. So simplifying the result, we have pi over 2. So what does this mean? It means that we move the graph pi over 2 units to the right since it is positive. Okay? Then, therefore, now each value from number 3 will be adjusted and to be added by the value of the phase shift, which is pi over 2. So pi over 4 plus pi over 2 is 3 pi over 4. And then pi over 2 plus pi over 2, that is pi for p over 2. Then 3 pi over 2 will be adjusted by pi over 2 also. So you add pi over 2. That will give us 5 pi over 4. And then for the final value p, which is pi, added by pi over 2, that will give you 3 pi over 2. Okay? Okay, so we are done with the fifth step. So the next thing that will happen here is we now going to we now go to step number 6, and that is determining the graph of the given function y equals 3 cosine of the quantity 2x minus pi by simply moving this yellow-green graph. We move this yellow-green graph by pi over 2 units to the right. Okay? Now, if we move this graph by pi over 2 units to the right, we will obtain the graph of this given function. Okay? Now, observe the Cartesian plane and look at the graph. And you will notice that from yellow-green, it is now changed to purple. And that purple graph is the one we're going to move. Okay? And that graph, which is the purple one, is the graph we're looking for. No? Yeah. So this graph is a result when we move the graph of the mother function, the green graph, by pi over 2 units going to the right. Okay? So again, this is the required graph, the purple graph. Okay? Next, we go to the fourth example, letter D. Probably this is the last one. Okay, how about y equals 3 cosine of the quantity 2x plus pi? Of course, we're going to trace the graph of this one. Again, let us follow these 6 steps. Let us consider the first 3, the amplitude. Okay, that is 3, which is the coefficient of cosine, and then the period p, which is equal to the formula, the absolute value of 2 pi over b, or 2 pi over 2, where 2 is taken from the coefficient of x, which is your b, and the period is equal to pi. Then from that value of period, we're going to divide that into 4 equal parts. So we go to step number 3. Now, p over 4 is pi over 4. The second part of the period is p over 2, or that is pi over 2. And then the third part, 3p over 4, or 3 pi over 4. And finally, p, which is equal to pi. Then, for step number 4, we're going to consider the mother function of this equation. So when we say mother function, we take away the constant term and retain what is to be left from the function, that is y equals 3 cosine of 2x. So at this point, we're going to trace the graph of this function, which is called the mother function of the given function. So we're going to prepare the Cartesian plane with some proper scaling or labeling of the coordinates along the x and y axis. Now, of course, the coordinates of y-axis can be determined by the amplitude, okay, which is the height of the graph. And we consider both the positive value or the negative value. Negative 3 is to be placed right here, the coordinate of the negative coordinate of the y-axis. Then, of course, considering each of the 4 equal parts of the period, we're going to use each of those and substitute to x of this given mother function. And then evaluate the value. So let's say pi over 4, that is cosine of pi over 2. Tama ba? Okay. Okay, cosine of pi over 2, that is actually, okay, 3 pi over 4. Okay, pi over 2. Cosine of pi over 2 is Now this is what we're going to do to trace the graph of the mother function y equals 3 cosine of 2x. Okay, we're not going to consider these four values or these four partitions of the period yet. Okay, we begin first with the zero coordinate along the x-axis. Okay, at 0 as the value of x. Okay, what will be the corresponding y value? Okay, so if we plug in 0 as the value of x here, so cosine of 0 is actually what? 1. And 1 times 3 is 3. So the first point will begin at 0 value of x, or the 0 coordinate of x axis. So obviously, we plot the point here. Then that's the time for us to consider each of these four partitions of the period. So starting with p over 4, we're going to substitute this to x from this mother function and evaluate the value of cosine. Then, okay, so at this point, let us consider p over 4 value and substitute that to this mother function, particularly as the value of x. So 2 times pi over 4, that is pi over 2. So cosine pi over 2 is actually 0 times 3 is 0. So at the value of x, so that is, so this is where you plot the point. Okay. Then for the second division of the period, p over 2 or pi over 2, substitute as the value of x. So cosine of pi, that will give you negative 1 times 3, it's negative 3. So this is where you plot the point. And then for the third partition of the period, 3 pi over 4, substitute. So it's 3 pi over 2. Cosine of 3 pi over 2 is actually 0 times 3 is 0. So this is where you plot the point. And finally, for the fourth value, which is the value of p or the period, so pi, 2 pi, cosine of 2 pi is actually 1 times 3 is 3. So at the value of x, which is pi, the corresponding value of y is 3. So this is where you plot the point. Now, as you can see, we have 5 plotted points na parang naka-V formation. You're not going to connect them by a straight line. You connect them using a smooth curve. And right now, let us do that, no? Ayun. Okay. Now, actually, the appearance of one cycle of the graph is from here up to this point. Okay? Itong sobra, ito ay parte nung isa pang cycle sa kaliwa. Ito naman ay part ng isa pang cycle dito sa side na to. Okay? So again, as I told you last time that the appearance of one cycle of the graph of cosine is actually similar to the shape of letter U or letter V. Okay? Okay. Then next, step number 5, we now determine its horizontal translation value or the phase shift value, which can be determined by the formula negative C over B, where C is the constant term inside the parentheses and B is the coefficient of X. Okay, so that is negative of pi over 2. So the value of phase shift is negative. What does this mean? It means that the graph of the mother function is to be moved pi over 2 units to the left. Yeah. Now, going back to number 4, each of the 4 parts of the period is to be adjusted by 2 pi over 2 units. So we're going to subtract each of these 4 values by pi over 2. Okay? So for p over 4, it becomes negative pi over 4. For p over 2, the value becomes 0. And 3 pi over 4, the value is pi over 4. And for p, the value from pi becomes pi over 2. And then for the sixth step, we are now going to trace the graph of the given function by simply moving the graph of the mother function by pi over 2 units to the left. Now observe the translation of the graph. Okay. Now the yellow-orange graph is the graph of the required function. Okay. Now this is the required graph. Okay. Okay, so that is how we trace the graph of sine and cosine function having the horizontal translation, either left or right. Now, if you don't have any question, so this is where we end the discussion and we will see you next time.